This is open channel. Okay, so ang pinakasikat dito, when it comes to open channel, so the analysis of canals used for irrigation, so how to compute the discharge, what will be the depth, and so on. So we have, for open channel, pinaka ginagamit dito is we have the Manning's formula. For the Manning's formula, okay, so unahin natin yung kanyang, or that is, we are able to derive this one last time, and the formula for velocity. The same formula for velocity last time, that is the same with pipe. The velocity equal to 1 over roughness coefficient, the hydraulic radius raised to 2 over 3, the hydraulic slope raised to 1/2. So we'll be having the hydraulic radius is equal to the area. This is divided by the wetted perimeter. So for example, or the most common type of open channel, we have the rectangular. Okay, so for the rectangular open channels, so for example, we have a rectangular open channel with the dimension base width B and a depth of D. So how to determine the area? We need the area of this rectangular channel is the same as B times D. How about what will be the equivalent of the wetted perimeter? So the wetted perimeter is basically the portion of contact, or is the line of contact of water or the discharge and the channel. So it's the same as we are just considering the base. So this is the base plus on one side left and right of the depth. That is the same as twice the depth. This will be the wetted perimeter. And the equivalent of their hydraulic radius. Hydraulic radius is equal to area over wetted perimeter. For a rectangular section, the hydraulic radius will be simply equal to area. That is B times D divided by B plus 2D. Okay? So, how to compute for the discharge? So basically, we have discharge is the same as area times velocity. The same concept with a pipe. That is the cross-sectional area of the flow times the velocity of flow. So we have for rectangular section, the discharge will be equal to area. That's the same as B times D. Velocity, this is 1 over roughness coefficient, hydraulic radius raised to 2 over 3, hydraulic slope raised to 1/2. So that will be the equivalent of discharge. So let's have an example. Okay, so example, let's have a rectangular open channel or rectangular canal. So a rectangular channel with a roughness coefficient n 0.015. The base width is 10.67 meters. To carry water at a depth of 0.85 meters. So the slope of the channel is equal to 0.0087. So determine the rate of flow. We are looking for the value of the discharge. Okay, so we can have first the area. The area for a rectangular channel is B times D. So we have the area is equal to 10.67 multiplied by the depth of 0.85. So let's have the area. So the area will equal to 9.0695 square meter. So about the wetted perimeter, yung contact lang ng liquid, the contact of the liquid to the channel, that is the base, plus both sides of the depth. Okay, so we have the wetted perimeter is the same as 10.67 plus twice of 0.85. So we have the wetted perimeter is equal to Alright, so we have 12.37 meters. So that is the area and the wetted perimeter. So let's now compute for the discharge. So we have the discharge is equal to area times velocity. We have discharge equal to, what is our area? It's the same as the area multiplied by 1 over the roughness coefficient, hydraulic radius raised to 2 over 3, S raised to 1/2, or the hydraulic slope. So we have the radius, or hydraulic radius, is the same as the area divided by the wetted perimeter. So let us substitute the values. So we have the discharge now equal to the area. We have 9.0695. This is multiplied by 1 over roughness coefficient, 0.015. Multiplied by the hydraulic radius, that is area over the wetted perimeter. So this is 9.0695. This is divided by 12.37. This is raised to 2 over 3. Hydraulic slope, it is given as 0.0087 raised to 1/2. So this will be in terms of cubic meters. So what will be the discharge? Okay, so we have a discharge equal to 45.856 cubic meters per cycle. Okay, so let's try a trapezoidal channel. So an earth canal carries water at a depth of 1.5 meters. So the canal is 6 meters wide on the bottom and has a side slope 2 horizontal, 1 vertical. So use N is equal to 0.025, S equal to 0.0002. Compute the discharge by Manning's formula. Okay, so the same lang, kahit nag-iba yung shape. We have the discharge equal to area times the velocity. So how to compute for the area of a trapezoid? Geometry, we have that is the top base plus the bottom base divided by 2 times the depth. So we need to determine the dimension of the top base. So let's say this is B. So this is the same as 6 meters. Let's say this is X. We can have it since given naman yung slope, that is 2 horizontal, 1 vertical. So this is 2 horizontal, 1 vertical. Horizontal dimension is X. The vertical is, that is 1 point, or let's say 1.5. So 2 horizontal, 2 is to X, 1 is to D. So we'll be having the X dimension equal to, this is 3 meters. So this is the same as X. So we'll be having the top base as, we have 6 plus twice of the dimension of X. So we have the top base will be equal to 6 plus 2x. So yung top base natin will be equal to 6 plus twice of 3. So we have a top base of 12 meters. Ayan. So we can now have the area. So the area of this trapezoid, the area is now equal to, we have the top base is equal to 12 meters plus 6, the bottom base. This is divided by 2. This is multiplied by 1 point, or the depth 1.5 meters. So we'll be having an area that is 12 plus 6, 18. Divided by 2 is 9 times 1.5 plus 4.5. This is equal to 13.5 square meters for the area. So how about for the wetted perimeter? The wetted perimeter is the contact of water to the channel. So we have 2 sloping sides. Yung naka-incline na side at saka yung bottom base. So let's say the inclined side as Z. So if this is 3 meters, we can have the dimension of Z by Pythagorean theorem. So the dimension of Z squared is equal to, that is the same as 3 squared plus 1.5 squared. So we have the value of Z is equal to alright, so this is the same as 3.354 meters. So that will be the value of Z. So ano naman yung value ng wetted perimeter? The wetted perimeter will be the same as the bottom base plus yung dalawang inclined sides. Let's say this is twice of Z. So we have the wetted perimeter is equal to 6 plus twice of this value. This is 3.354 meters. So wetted perimeter is now equal to is equal to 12.708 meters. Ayan. Then, okay. You may na complete for the discharge. So you have the discharge is equal to area, velocity by Manning's, that is 1 over n, hydraulic radius raised to 2 over 3, hydraulic slope raised to 1/2. So you have the discharge is now equal to area. The area is equal to 13.5. This multiplied by 1 over roughness coefficient, we have 0.025. Hydraulic radius is again area divided by your wetted perimeter. The area is equal to 13.5 divided by wetted perimeter, 12.708. This is raised to 2 over 3. And the given slope, 0.0002 raised to 1/2. So let's compute for the discharge. So we're having a discharge equal to 7.951 cubic meter per second.